Welcome everybody to Algebra 2, Section 6.4, Dividing Radicals. So, for dividing radicals, we're going to be doing a similar process to when we multiplied radicals. We'll be dividing the outsides, the coefficients, and then we're going to be dividing the insides. So, this will be using the quotient rule, where you can have two separate radicals, and you can have that as the quotient or division of one big radical. Now, this only works if these are both the same root or index. So for example, they'd both have to be the square root or the third root or the fourth root. And we won't have any problems or anything like that to where they are different roots or anything. So we'll only encounter problems where they are the same root. So no worries there. Now we don't technically have to rewrite it this way. Just know that these are equivalent between these two. And then you always simplify your resulting radical. So on number 1, 12 and 2, the coefficients, the regular numbers, the outsides, we'll simplify those. 12 divided by 2 is 6. On the inside, we do the square root of 160 and the square root of 5. We do 160 divided by 5. That is 32. So we do the square root of 32. Now, we just simplify the square root of 32. So that's 6 times the square root of 16 times the square root of 2. That would be 6 times 4 times the square root of 2, because the square root of 16 is 4, giving us 24 times the square root of 2. On to number 2. Same idea here, we just have fourth roots this time. So we do 36 divided by 9, which is 4. Then we have the fourth root of whatever 1,250 divided by 2 is. It's 625. Now 625 happens to be a perfect fourth. It's 5 to the fourth. So it's 600. So the fourth root of 625 is 5. And 4 times 5 is 20. Moving on to number 3. Variables here. So only things inside the square root. Remember when we divide the same base, x and x, or y and y, we subtract the exponents. So here we get the square root of x to the first and y to the fourth, as we do 3 minus 2 and 9 minus 5. Then we go part by part. So square root of x, square root of y to the fourth. Square root of x would be x to the power of 1 over 2, which doesn't simplify or become a mixed number. X to the power of 4 over 2 does in fact simplified x to the power of 2. And so this, as our final answer, would be x squared. Sorry, I said x. That would be y. And then times the square root of x. Man, I wrote x again down in the blue there. Darn me. That's better. And then in the purple, I started writing. Oh my gosh, I made a mistake in my purple too. Ah, what a chaotic problem for me. All right, let's try this again. Y squared times the square root of x. That would be correct, because this is the y squared that goes outside the radical. This is the 1/2, so it's x to the first underneath the radical, the root of 2. All right, now on number 4. We have outsides and insides. So on the outsides, 28 divided by 4 is 7. On the insides, negative 16 divided by 2 is negative 8. And m to the 6 divided by m, we do 6 minus 5, we get m to the 5th. So as we do part by part, cube root of negative 8 and cube root of m to the 5th. Cube root of negative 8 is just negative 2. And then cube root of m to the 5th is m to the power of 5 over 3, which we just rewrite as m to the power of 1 and 2/3 as a mixed number. So this negative 2 and the 7 multiply together to give us negative 14. I'm going to make that negative a little more emphasized in that too. The m to the first is outside the radical. And the m to the 2/3 tells us it's the cube root of m squared. And now we're on to number 5. Number 5, cube root of 48 over square root of 48 over square root of 16. Ignore the fact that 16 is a perfect square for a moment and just reduce. So 48 divided by 16 is 3, square root of 3. That cannot simplify, so we're done. Number 6, cube root of 40 over 27. We look to see, can we reduce 40 and 27? The answer is that we cannot reduce them. So we want to look for perfect cubes of each. So cube root of 40 over the cube root of 27. Cube root of 40 is the cube root of 8 times the cube root of 5. Cube root of 27 is just 3. So this becomes 2 times the cube root of 5 over 3. On to number 7. Once again, we look to see if we can simplify. We can't. So we're just going to go through and handle this part by part. So I'm going to do the cube root of 7, cube root of x to the 5th, cube root of 64, and cube root of y to the 6th. Cube root of 7 just simply stays cube root of 7. Can't simplify. Nothing. No perfect cube is a factor. Cube root of x to the 5th is x to the power of 5 over 3, which can be rewritten as x to the power of 1 and 2/3. Cube root of 64 is just 4. And cube root of y to the 6 is y to the power of 6 over 3, which is just y to the power of 2. So then this, we have x to the 1st outside the radical, 4 outside the radical, y squared outside the radical. And we leave things where they were. So the x is on the top of the fraction, the 4 is on the bottom, and the y squared is on the bottom, because that's where the x, 64, and y's were on originally to match. Then on the top we have the cube root of 7x squared. We have the cube root of 7, and then this 2/3 tells us it's x cube root of x squared. And the bottom we don't have any more cube roots. So that's our answer. Moving on to number 8. Once again, we look to simplify. We can't simplify 32 and 81, so we'll go through part by part. 4th root of 32, 4th root of w, 4th root of 81. 4th root of 32 is the 4th root of 16 times the 4th root of 2, which is 2 times the 4th root of 2. 4th root of w to the 1/4, which doesn't simplify or reduce, so we're just going to take it back and make it the 4th root of w again. 4th root of 81 is just 3. So put things back where they were. As far as top and bottom goes, and so on the top we're going to have 2 times the 4th root of 2w. On the bottom we'll have 3. Now we're going to rationalize the denominator. What we mean by this is we do not want a radical to end the answer on the bottom or in the denominator. We had this rule back before when we dealt with just square roots, and we have the rule again now that we're dealing with cube roots as well, or 4th roots. And we're actually just going to be doing it with square roots here though. Now, how we approach this depends on whether the denominator is a monomial or a binomial, whether there's one term or two terms. We also did this with imaginary numbers, you may remember. Now, when there's a monomial, you multiply the numerator and denominator by the radical, which is what we'll be seeing first. So I'll talk about that for now. Then when we get to the binomials, I'll talk about what we do for those. So on 9, 3 over 2 square root 5. We'll look to see if we can reduce anything. We can't. We have a radical in the denominator. We don't want that. We're fine with this 2 down there. We're fine with this 3. We're just not fine with this square root of 5. That's our only issue. So we're going to multiply the top and bottom by, specifically, the square root of 5. Now the reason we choose the square root of 5 is because, as we saw in section 3, is that the square root of anything times itself is the radicand, or what's inside. So the square root of 5 times square root of 5 is 5. So that means we get 2 times regular 5, or 10, in the denominator. On the top, we get 3 times the square root of 5. Now we no longer have a radical in the denominator, thus accomplishing our goal. We again check to see if we can simplify anything. Again, we can't, so now we're done. Moving on to number 10. Number 10, we first check to see, can we simplify anything? The answer is, unfortunately, we cannot. I encourage us to simplify this, or excuse me, separate those. Now, you may want to simplify the numerator at this point because you recognize I can simplify the square root of 8. And it's fine if you do, it's fine if you don't. It really is okay either way. Now, if you could simplify the denominator, you most definitely want to. And I will talk about why you'd want to do that in a little bit. We'll come upon an example in 14 as to why you'd want to do that. But as far as this goes, it's not any sort of concern to us right now. So I'm going to go ahead and multiply by the square root of 15 once again, whatever square it's on the bottom. And if you wanted to go ahead and simplify the top before this, that's fine, into 2 times the square root of 2. So now we do 15 times 8, and we end up getting the square root of 120 over 15. And so now we simplify the square root of 120, which is square root of 4 times square root of 30 over 15. Square root of 4 is 2. And so we get 2 times the square root of 30 over 15. You would check to see if you can simplify the 2 and 15. You can't. Moving on to number 11. We check to see if we can simplify anything. We can't simplify the 12 and 7 inside the radical, nor can we simplify the 3 and 4 outside the radical. You might want to simplify the square root of 12 right now. Feel free to. If you don't, it's fine either way. It doesn't have an impact on this problem one way or the other. I'm going to go ahead and multiply the top and bottom. Here I only need to multiply by the square root of 7 though. And the reason why is I'm not concerned that the 4 is down there. I'm only concerned that the square root of 7 is down there. So in the numerator, I'm going to have 3 times the square root of 84. In the denominator, I'm going to have 4 times 7, which is 28. So the numerator, that's 3 times the square root of 4 times the square root of 21, because 4 is a perfect square. In the denominator, that's 28 again. So numerator, 3 times the square root of 4 is 3 times 2. So I have 12 times the square root of 21 over 28. We check to see if we can simplify, and this time we can. Oh, excuse me, that wouldn't be 12, that'd be 6 for my numerator. These would be 3 times 2, not 3 times 4. So now we simplify 6 and 28 by 2, giving me 3 square root of 21 over 14. On to number 12. Once again, we check to simplify first if we can. 32 and 3 don't simplify, but the a's do. So we get the square root of 32, 8 to the 4th, over 3, square root of 3. Now we'll need to multiply the top and bottom by the square root of 3. This will give us the square root of 96 8 to the fourth over 3. And now we want to simplify the square root of 96 8 to the fourth. So the square root of 96 and the square root of 8 to the fourth and the square root of 96 would be the square root of 16 and the square root of 6, which is 4 times the square root of 6. And the square root of 8 to the fourth is 8 to the power 4 over 2, or just 8 to the power 2. And so that gives us 4a squared times the square root of 6 all over 3. And if the 4 and 3 simplified, we would, but they don't. So we're done. Now we'll move on to number 13. Counting is hard sometimes, I suppose. 8 minus square root of 8 minus square root of 2 over square root of 2. So, a couple of different ways we can handle this problem. I'm going to first talk about the easier way, and then I'll talk about the longer way. So the easier way is to split this into two different fractions. Square root of 8 over square root of 2 minus square root of 2 over square root of 2. So you can always split fractions, split the numerator into multiple fractions over the denominator. Now you can divide these. So square root of 8 over square root of 2 is square root of 4, minus square root of 2 over square root of 2 is anything divided by itself other than 0 is 1. You could also say it's the square root of 1, which is 1. And so now you have the square root of 4 minus 1, which is 2 minus 1, giving us 1. So that is the faster way to solve this, and the way I would recommend solving this. Now, there is another way to solve this one, which I'll talk about right now. So if we start off with the same exact problem, the square root of 8 minus square root of 2 over square root of 2, is you could, very much so, multiply top and bottom by the square root of 2 to rationalize it. And you would distribute on the top. We practiced distributing radicals in 6.3. And so you get the square root of 16 minus the square root of 4 over 2. And that is 4 minus 2 over 2, which gives us 2 over 2, aka 1. So we still end up with the exact same answer, and they don't always work out quite this cleanly either way, like they do on this one. Now, once again, I mentioned that I consider this one to be longer. They end up actually taking about the same amount of steps on this problem. I suppose maybe they do on most times. Maybe it's just that I just prefer the one on the left. But regardless, pick whichever one makes more sense to you at the end of the day. I don't necessarily care what you end up deciding what you want to do. What matters is that you end up doing what makes more sense to you. On number 14, we have another scenario where we have the same kind of problem here. Except also we have the square root of 12, and the reason that's relevant here is because we can simplify the square root of 12, and we're going to work on that in just a moment. Actually, depending on which way we go about this problem, I should say, because what you do might change depending on that. So let's say I split the fraction first. I'm going to go splitting the fraction, and then I'll talk about what happens if you don't split the fraction. So 3 square root 2 plus square root 6 each over square root of 12. Then I'll look to simplify. I can simplify the 2 and the 12 inside the radicals to 3 over square root 6. It would technically be 3 times the square root of 1, but the square root of 1 is just 1, and 3 times 1 is just 3, so unnecessary to write, plus the 1 over square root 2, and once again, it'd be the square root 1 on top, which is just 1. And now in this first fraction, I need to multiply the top and bottom by the square root 6, giving me 3 square root 6 over 6. The second fraction, I need to multiply the top and bottom by square root 2, giving me square root 2 over 2. And so this left one simplifies into square root 6 over 2 plus square root 2 over 2. And since these have the exact same denominator, you could choose to smush them back together into one radical, or excuse me, one fraction. Or you could choose to leave them separate. I don't care which one you pick as far as leaving them separate or putting them back together as one fraction. So once again, this is how you would go about the problem if you were to split the numerator into multiple fractions and work on simplifying each of them and rationalizing each of them. Now let's talk about what you would do in the problem if you were to leave it as one fraction. So there's actually two different ways you could handle this. So I'll talk about way number 1, and that's just by multiplying the top and bottom by the square root of 12. So we distribute, and we end up getting 3 times the square root of 24 plus the square root of 72 over 12. 3 times the square root of 24 simplifies into 3 times the square root of 4 times the square root of 6. And square root of 72 simplifies into the square root of 36 times the square root of 2. And so 3 times the square root of 4 is 3 times 2, aka 6, square root 6. And square root of 36 is 6. And then we can simplify the regular, normal, 6, 6, and 12, since they all reduce by 6, giving us, if my iPad would let me scroll, square root 6 plus square root 2 over 2, which is the exact same answer we got before. So some of us may find this simpler. There's only one fraction to deal with, only one thing to multiply by, and one thing to and one set of things to reduce, rather than multiple things. So if you find this one simpler, great, awesome, good for you. Please do that. If you find the first one simpler, great, awesome, good for you. Please do that. And maybe you'll like this other one that we'll do. We'll talk about it as an option. So last potential option here. If you have the square root of 12 on the bottom, we can actually simplify the square root of 12. The square root of 12 is the square root of 4 times the square root of 3, which is 2 times the square root of 3. So that gives us 3 times the square root of 2 plus square root 6 over 2 square root 3. And then at this point, you could either split the fraction like we did on the far left initially, or you could leave them as separate fractions, or leave them as the same fraction like we did in the middle, the second thing we did. I'm just going to leave them as the same for this example and multiply the top and bottom now by just the square root of 3 rather than the square root of 12, because that's the only radical on the bottom. So now the benefit to this is that the number we're multiplying by, the radical we're multiplying by, is smaller. And so I get 3 square root 6 plus square root 18 over 2 square root 3. Sorry, try that again. Over 2 times 3, which is 6. There you go. I knew I made an error. I was buffering. I was trying to figure out what it was. Then square root of 18 simplifies into square root of 9 times the square root of 2, which, that's 3 times the square root of 2. over 6. And again, we're in the scenario where we need to simplify the regular numbers, the 3, and the 6. This time they all simplify by 3. And we get square root 6 plus square root 2 over 2. And we get the exact same answer, you'll notice, no matter which of the 3 ways we approach the problem. It didn't matter. So the final way just kept the number smaller, was the nice part. I guess the first and third ways kept the number smaller, just with different approaches. So once again, 3 different ways to approach a problem, and you really could have had a fourth depending on if you split the radical at this step, or split the fraction of that step, excuse me, not radical. Number 15. So now starting on 15 through 20, we're going to be doing binomials. So let's talk about what to do a binomial when you have 4 plus square root 2, okay? Now, don't write this down, but essentially what I want you to get from this is if you were to multiply the top and bottom by the square root of 2 here, it wouldn't go well. And by that I mean it wouldn't accomplish your goal. So you would get like 4 square root 2 over 4 square root 2 plus 2. And shoot, you still have a radical on the bottom. Didn't help. Okay, well maybe you multiply by square root 2 again. Maybe this will help. So you multiply by it again. And you get 4 times 2 on the top, and that's 8. On the bottom you get 4 times 2, which is 8, plus 2 square root 2. And it's like, no, now I just have a radical on the second term again in the bottom. And you just we're back in the same boat with just bigger numbers that you would have to reduce. And maybe you're like, oh, okay, maybe I'll multiply again by the square root of 2. And you just get caught in this endless loop where you're shifting which term in the denominator has the radical, never actually accomplishing your goal of making it so neither term in the denominator has a radical. So instead of just going in this endless loop and getting frustrated, we're going to have to do something different. And that something different is actually very similar to what we did with imaginary numbers when we had to rationalize the denominator. So let's go back a page and talk about what to do here. So we multiplied the numerator and denominator by what we call the conjugate. It's the same expression, but we do the opposite sign in the middle. Now note, only the middle sign is the opposite. So if there's a sign before the first number that is negative, you don't change that. It's like if there's a no sign before the first number, we assume it's positive, and we don't change that either. So on number 15 here, for example, we're going to multiply the top and bottom by, instead of 4 plus square root 2, by 4 minus square root 2. And if, for example, this had been a negative 4 square root 2, we're going to multiply it by negative 4 square root minus 2. Or 4 minus square root 2, excuse me. So the only thing that changes is the sign in the middle. It becomes the opposite. So now we multiply this on the top and the bottom. So the top we do 4 times 4 and 4 times negative square root 2, and we get 16 minus 4 square root 2 over, and we have to distribute, we have to FOIL here, so we're going to get 4 terms. We do 4 times 4 and get 16. 4 times square root 2 and get negative 4 square root 2. Square root 2 times 4 and we get 4 square root 2. Square root 2 times square root 2 and we get negative 2. Now, on the bottom here, we combine like terms. I don't know why I put that little line there on the bottom there as if it was a radical. So the top is just going to stay the same. And the bottom, 16 minus 2, the regular numbers, is 14. And here, these zero out, which is the whole reason we did this, is because now we don't have any radicals in our denominator. Now, at this step, we need to check, can we simplify each of these regular numbers by the same number? And the answer is yes, we can. They all can simplify or reduce by 2. So we get 8 minus 2 square root 2 all over 7. And that'd be our answer. On to number 16. On to number 16, our conjugate that we'd multiply by is the same as the bottom. The middle sign changes. So 6 plus the square root 5. So as we do this, we do 2 times 6 and 2 times the square root of 5. So we get 12 plus 2 times square root of 5 over 6 times 6, 36. 6 times the square root of 5, 6 square root of 5. Negative square root of 5 times 6, negative 6 square root of 5. Negative square root of 5 times square root of 5 is just negative 5. You'll notice a consistent pattern here in the denominators when you multiply the two conjugates together, that these are always going to be opposite each other, which is exactly how they're designed to work. So that way they zero out. So the numerator is 12 plus 2 square root of 5, and the denominator just gives us 31 as we combine the like terms of the 36 and negative 5, and the middle terms of 6 square root of 5 and negative 6 square root of 5. And 12, 2, and 31 don't reduce, so we leave this as our answer. On to number 17. On number 17 here, our conjugate would be 1 plus 4 square root 2. Square root of 3 times 1 is square root 3. Square root 3 times 4 square root 2 is 4 square root 6. That doesn't simplify. If it did, we'd have to. In the denominator, 1 times 1 is 1. 1 times 4 square root 2 is 4 square root 2. Negative 4 square root 2 times 1 is negative 4 square root 2. And negative 4 square root 2 times 4 square root 2. Negative 4 times 4 is negative 16. And square root 2 times square root 2 is 2. So that is negative 32. If you need to see that written out, I'll show it off to the side here. So negative 4 square root 2 times positive 4 square root 2 would be negative 16 times 2, which once again is negative 32. So in the denominator, we'll combine like terms. Numerator stays the same because we can't combine them or simplify either radical. So 1 minus 32 is negative 31, and the middle terms zero out. Nothing simplifies, and we're done. Moving on, number 18. So now we have a binomial in the top two. That just means we're going to have to FOIL on the top two. So we're still going to have the denominator be, or excuse me, we're still going to have our conjugate be square root of 5 minus square root of 3, even though these are both radicals now. That's okay. So 5 times square root of 5 is 5 square root of 5. 5 times negative square root of 3 is negative 5 square root of 3. Negative square root of 5 times square root of 5 is negative 5. My iPad just glitched. Negative square root of 5 times negative square root of 3 is positive square root of 15. None of those simplify or have anything in common, so they're all just going to stay the same. We're just going to have 4 terms in our numerator. The denominator, I'm going to use a different color so you can actually see it. Square root of 5 times square root of 5 is 5. Square root of 5 times square root of negative 3, or negative square root of 3 rather, is negative square root of 15. Square root of 3 times square root of 5 is positive square root of 15. And square root of 3 times negative square root of 3 is negative 3 rather. So the denominator doesn't work out badly at all, actually. So the numerator, the dumpster fire that's up there, is 5 square root of 5 minus 5 square root of 3 minus 5 plus square root of 15. And I truly do not care the order you have the numerator in, to be clear, as long as all the signs and numbers and radicands are individually correct. And denominators, you combine like terms. 5 minus 2 is 3. And you can't simplify all the outside numbers. This one doesn't even have an outside number. And the middle terms of negative square root of 15 and positive square root of 15 zero out. Number 19. So here our conjugate would be 2 minus 2 squared root 7. So 3 times 2 is 6. 3 times 2 squared root 7, negative 2 squared root 7 is negative 6 squared root 7. Square root 7 times 2 is 2 squared root 7. Square root 7 times negative 2 squared root 7 is negative 2 times 7, which is negative 14. On the bottom, 2 times 2 is 4. 2 times 2 is negative 2 squared root 7 is negative 4 squared root 7. 2 squared root 7 times 2 is 4 squared root 7. Those are the middle terms I'll zero out. And then 2 squared root 7 times negative 2 squared root 7. I'll write this off to the side for those that may benefit. Lots of us may. 2 times 2 is negative 4. Square root 7 times square root 7 is 7. And that gives us negative 28. So the top, we can combine the 6 and the minus 14 to get us negative 8. We can also combine our square root 7s to give us negative 4 square root 7. A lot less messy than the last one. On the bottom, 4 minus 28 is negative 24, and the middle term 0 out. Here we can actually simplify by 4 on the top and bottom, so we do. By negative 4 specifically. And so we get 2 plus 1 square root 7, or just square root 7, over 6. You could also choose to write this as 1 over 3 plus square root 7 over 6, where you split the fraction and simplify the 2/6 as well. If that makes sense, awesome. If not, that's fine. Ignore it. Number 20, our last problem for the day. We'd multiply the top and bottom here by 3 plus 4 square root 6. Eight times 3 is 24. 8 times 4 square root 6 is 32 square root 6. Negative square root 6 times 3 is negative 3 square root 6. Negative square root 6 times 4 square root 6 is 4 times 6, which is negative 24. On the bottom, 3 times 3 is 9. 3 times 4 square root 6 is 12 square root 6. Negative 4 square root 6 times 3 is negative 12 square root 6. Negative 4 square root 6 times 4 square root 6. That would be the thing I was writing out earlier, which would be negative 4 square root 6 times positive 4 rather, square root 6, which is negative 16 times 6, which is negative 96. So minus 96. And so the numerator, 24 minus 24 is 0. We combine the square root 6's and we get 29 square root 6. In the denominator, 9 minus 96 is negative 87. The middle term 0 out. Can we simplify 29 and 87? Yes, by 29 actually. And you get square root 6 over negative 3. And that wraps up section 4 of Algebra 2.